Hello, I am Ankur Gupta, and I will be talking about my summer research project using recurrent neural networks for future car crash predictions. It is doubtless that there is a trend towards self-driving cars in the autonomous industry. Many of the major companies, Google, Tesla, Volvo, Mercedes-Benz, just to name a few, are all working on creating autonomous vehicles. The effect of these autonomous vehicles The effect that these autonomous vehicles will have on humanity are doubtlessly large. With over 1 billion cars in 2011, even the smallest errors in autonomous vehicles can yield thousands of fatal car crashes. The problem with current self-driving cars is that they use real-time sensor data to make decisions on a road. This can be seen in the slide where a Google self-driving car can, quote-unquote, see its environment by utilizing various sensors located throughout the car. However, why is it a problem? The key issue is that these cars are making decisions on what is happening on the road at the moment when the data was collected. This is fine for slow traffic, but on situations on a freeway or a highway where cars can be going 80 to 90 miles per hour, the current state of the road is less important than what the state of the road will be in the near future. Humans actually work like this, in which we are constantly predicting the future on everyday driving, yet traditional programming algorithms are limited to the current time and position of an object. This is where recurrent neural networks, specifically LSTM cells, come in. These systems deviate from traditional algorithms in which they quote-unquote learn how to solve a problem through repeated examples, similar to exactly how humans learn. Another major benefit of LSTM cells is that they actually take in a sequence of data and make a prediction based on what is happening in the present as well as what is happening in the past. For example, imagine a film strip. What an LSTM can do is that it'll analyze different components of the film strip, such as the man throwing up a ball and him getting ready to hit it, and it can make a reasonable prediction on what the next frame will be. Similarly, in the application of my project, the LSTM will be able to analyze the current road situation and predict if there is going to be a car crash in the near future. However, as mentioned before, in order to train the algorithm, there needs to be standardized data, and a lot of it, for the algorithm to learn on. Because there is no standardized data set for the point of view of a driver, I had to create my own data collection robot to generate the data. I designed, laser cut, and built a custom robot using AutoCAD. This robot was powered by a Raspberry Pi and an Arduino Uno. This robot was then programmed to move about autonomously, varying speed and direction. While driving around, carrying both video data as well as velocity and direction data, I drove around another remote control car alongside the data collection robot. I performed common driving practices such as overtaking, driving on the other side of the road, speeding, three-point turns, and crashing into the data collection car to create a varied and decently realistic data set. Finally, when the data was collected, I built my program using Google's open source deep learning library TensorFlow. I trained my algorithm on the dataset and ended up with a 30% error rate for 0.26 seconds to 1 second notice before the crash. Although the number may seem high, it actually means that this algorithm was able to predict 70% of crashes in the future. If this technology were to be integrated with current systems in such a way that the machine learning algorithm could alert the self-driving car to start performing preventative maneuvers before the crash even happened, then there's a very good chance that the fatalities due to self-driving cars will be reduced to a minimum. Again, I am Ankur Gupta, and this is my submission for the Davidson Fellows Scholarship. All the resources that are used in this presentation can all be referenced within my research paper.